Hi everyone, welcome back to your own YouTube channel Infinite Iteration. Before starting this video, I would like to make a small request to you guys. If you find my videos helpful, valuable and like it can benefit you in any way, then it's a small request, it's a humble request to please subscribe to my YouTube channel because it will motivate me to produce more content. Because guys, I am going to give you free content, highly paid courses like I did over the years, like AI, machine learning, DevOps, cybersecurity, everything, all the latest technologies and all the computer science courses from bachelor level up to PhD level. I will give you for free. So in return, I just ask you to please subscribe and watch my videos completely. Okay, without a further ado, we will start this video. So today we will talk about job, task, process. Job is basically a work that needs to be done, everyone knows that, and task is just a small unit of work, like it's a subset of a job. Process itself consists of several tasks, like several tasks to be executed. As you can see in this figure, like we have one job and it consists of several tasks. So what is a process? So basically program is passive and process is active. Program before execution is not a process. When we execute a program, it becomes a process. A process is not a program, as I told you before. It is basically an instance of the program at the time of execution, and process includes complete execution code. It is basically loaded into the main memory RAM. So basic comparison. Program is a set of instruction, while process is a program in execution. Program is passive, process is active. Program lifespan is longer, process, as you can read by your own self too on the slide that I made for you. Program is longer, process is limited. Program is stored in some file while process holds resources, CPU resource, computer resources. Okay, let's discuss about CPU bound process and IO bound process. So such process that spends more time performing computation tasks than IO tasks are called CPU bound process, while IO bound process spends more time performing IO tasks than computation tasks. So here's a small self test of what we have learned before. What is the difference between a job, task and a process? Pause this video now and answer yourself. Okay, I hope you answer it correctly. Multitasking operating system. So basically we have discussed in our previous video about multi-programming, and now we are going to discuss multitasking. Multi-programming is just like we have multiple programs loaded onto our main memory and we basically context switching between each of them. And while multitasking is just we have several tasks that needs to be done, and we also perform context switching in this case as well. As you can see, multitasking, task 1, task 2, task 3, and CPU allots 10 nanosecond for each task. They don't feel any time sharing, time slicing, but in reality there is a time sharing between them. And as you can see, multitasking, like we have context switching of web browser, MS Word, email, VS Code. A user is concurrently working on these 4 apps and it's context switching between each of them. So why is it called a context switch? Basically the term context switch refers to the specific state or environment in which a process or thread is currently executing. So that is how context switch is termed as. And context switch in the case of multi-programming. So multiple programs are loaded into memory, so CPU always has something to execute when one program is waiting for the IO. So what does it mean? Like when the CPU becomes like finished one job, so it switched to another job, and in between it's wait for the IO. So its goal, its maximum CPU utilization. Multitasking, it's basically the switches rapidly switches between different tasks. CPU switches between different tasks. It basically provides an illusion that multiple tasks run simultaneously, but I already told you there is a small amount of like nanoseconds of time sharing. Its goal is improved responsiveness. So context switching, as I told you before, it is the act of saving the state context of one process, thread and loading the state of another, so execution can resume later from the same point. Okay, multitasking operating system. Multi-programming is based on context switching, whereas multitasking is based on time sharing, as I told you before. Memory and your CPU utilization. In multi-programming, multiple programs reside in main memory simultaneously to improve CPU utilization and reduce idle time. Multitasking enables simultaneous execution of multiple tasks and processes to increase CPU performance. And you can see like CPU usage, multiple program utilizes a single CPU while multitasking requires multiple CPU. Execution time, multi-programming takes more time, multitasking takes less time. Objective behind it's like multi-programming is to reduce CPU idle time, while multitasking aims to allow multiple processes to run simultaneously via time sharing. So now we are going to discuss about network operating system. It's basically like we have different autonomous independent computers connected over a network, and it's basically two types of architecture: client server network and peer-to-peer network. So what is a client server architecture? A clear separation between clients and server, while peer-to-peer no differentiation, no difference between clients and server. Data is only provided in response to a request in client server, while peers have the authority to request as well as provide a service. It is a centralized system. It has, while peer-to-peer it has own data and application. Client server purpose is to store and exchange information. Peer-to-peer goal is to maintain connections among peers. Client server is suitable for small as well as large network, while peer-to-peer suitable for less number of users or devices. So client server is better. Embedded operating system. Embedded operating system is basically, as you can see in IoT devices like Internet of Things, like Raspberry Pi, microcontrollers or industrial robots. We have embedded operating system, and it works on real-time processes and generates data. So it is basically for IoT devices, embedded operating system. Following are some examples: smartphone, tablet, automotive system, industrial automation systems, medical devices, smart home devices. So embedded operating system, it's basically resource efficient, it has real-time capabilities, it performs specific functions not for broad range of categories. It is reliable, it has hardware abstraction. So embedded operating system, as you can see, it's basically for microcontrollers or Raspberry Pi, IoT devices, ABS braking system, and aerospace, medical devices, industrial automation, and smart thermostats, stuff like that. So it's basically application of embedded operating system. Examples of embedded operating system is FreeRTOS. RTOS is basically means real-time operating system. Embedded Linux, VxWorks, QNX. So we will discuss distributed operating system. So here we have like different computers, and it's distributed and connected over a distributed network, and each have own local operating system. So failure of one system will not affect the other because it is distributed. The load on the system is reduced because it is distributed. The size of the network is scalable. You can add more computers onto it, and as the workload and resources are shared, therefore the calculation are performed at higher speed because it is distributed, load is distributed. Data exchange speed is increased, as you know, because it has multiple computers, but the setup cost is high. Software used for such system is highly complex. Failure of the main network, like if the main network goes off, like everything will be shut down. So it's a failure of the whole system. Now we will discuss real-time operating system. Real-time operating system, as I told you before, RTOS. RTOS basically for real-time implementation of anything. So we want real-time processes to be executed at real time. We want real-time results. So it's basically real-time operating system, and applications are industrial control, telephone switching equipment, flight control, and real-time simulation. It is commonly used in heart pacemakers, robot, network multimedia systems. As you can see, real-time operating system has the following characteristics: timely task execution, determinism, minimal latency, efficient resource management. So RTOS, prioritize and scheduleize your process. It is resource managed by its own self. It has minimum latency. It is lightweight and efficient. Types of real operating system. So it has three basic types: hard real-time operating system, soft real-time operating system, and firm real-time operating system. Soft real-time, it's basically like if you miss some deadlines, like if some task or some process is not executed, it does not affect the whole operating system. It does not consider as a failure. So it is non-deterministic. Failure can happen, but it does not mean that it will destroy your whole system. So use cases: personal computers, online gaming, we can have some delay. So it's soft real-time operating system. Hard real-time operating system, missing a deadline is a critical failure. You cannot miss a deadline. It is deterministic. Task execution is predictable and guaranteed within an exact, precise time frame. Failure in a single, like missed deadline or something, it will result in a total failure. So it focuses on reliability and safety. Like if some country is launching nuke to another country, we cannot have any delay, otherwise we will miss the target. Like in missile, like we cannot miss the target. So it is basically the application of hard real-time operating systems. And firm operating systems, like we can miss occasional deadline, but not always. If it is frequently missing deadlines, then it is a failure. So it is a firm real-time operating system. It has application like multimedia playback and streaming. Like if I am doing live streaming and if our operating system missed a deadline, so it will not result in a total failure, but if it continuously happening, then it will result a failure. So real-time operating system has the following advantages and disadvantages. It provides more output from all the resources as there is maximum utilization of system. It provides the best management of memory allocation. These systems are always error free. These operating systems focus more on running application than those in the queue. Shifting from one task to another task takes very little time. Disadvantages: system resources are extremely expensive and are not so good. The algorithm used are very complex. Only limited tasks can run at a single time. In such system, we cannot set thread priority as these system cannot switch tasks easily. So now we will discuss threads. Before starting, I will give you a brief intro of threads. So we have programs, process, and threads. Process is a subset of program, is a small unit of program, while thread is a subset of process. It is a small unit of process. So it's a brief definition of all these three. Program is basically set of instructions. So we have multitask operating system, multi-programming operating system, and we have multi-threaded operating system. So its basic purpose, its thread is separate. It provides separate execution path for each threads. The operating system creates and manages threads, and they share the same memory. So threads basically share the same memory address and address space, same memory. Thread control block, we will discuss in later part of our playlist. Process control block and thread control block. So it is allocated the same memory address and same resources. So it is all in one place. All the threads are in one place, while process can be separated. Like one process is at one place and another process is at another place. As I told you, here you can see program has multiple processes, process 1, 2, 3 and so on, while process has multiple threads 1, 2, 3 and so on. Multi-threaded, the idea is to achieve multi-threaded operating system. The idea is to achieve parallelism by dividing a process into multiple threads. Like if a user is working on MS thread, one thread is format the text, while other one is checking the grammar, while other is something like editing or highlighting mistakes or errors. So it's basically an application of multi-threaded operating system. As you can see, program versus process versus thread, as I told you before. So it's a brief difference between process and threads. Execution of any program is a process, and subset of a process is a thread. Communication, process takes more time, threads takes less time for communication. process it's consume more resources, threads consume less resources. Memory, the process does not share the same memory address, while threads share the same memory address. Data sharing in process is difficult because one process might be lying on one place while the other is at another place, so data sharing is difficult. While in threads, data sharing is very easy. Size, the process consume more size because it's a subset of a program, and as I told you before, the thread is a small unit of a process, so threads are lightweight. And execution error, one process will not affect any other process. Threads will not run if one thread has an error, so that is a disadvantage of thread. Termination time, process usually takes more time to terminate, threads take less time to terminate. So there's a difference, as I told you before, resource sharing, communication, and enhanced throughput. So if a process is divided into multiple threads, what is the throughput? Throughput is output per unit time. So if a process is divided into multiple threads and each thread function is considered as one job, then the number of jobs completed per unit of time, like throughput, is increased. So throughput is increased in the case of threads. Advantages of thread, it is highly responsive, it provides faster context switch, and it is basically its main function is to effective utilization of multiprocessor system. As you can see, single core and multi-core, like we have here one core, and on the right we have two cores system, multi-core system. As you can see, application of a thread, each core have a separate thread. Thread 1 contains core 1, like core 1 contains thread 1, core 2 contains thread 2, and core 3 and core 4, so on. So it's a multi-core processor, and you can see it's the diagram of multi-core and multi-threading technologies. It's basically quad-core Intel processor. From quad-core Intel processor, we have multi-core and multi-threading technologies. So brief description on this difference between 16-bit and 32-bit. 16-bit, as you know, 32-bit, as you know, sorry, say 32-bit and 64-bit. There's a slide mistake in the slide. It shows 16-bit and 32-bit, while it is 32-bit and 64-bit. 32 bits basically 4 gigabytes of RAM, and 64 bits has like 264 memory address or 18 quintillion gigabytes of RAM. 32 bits basically allows your application of 32 bit to be run on it, while 64 bit can run either a 32 bit or a 64 bit operating system. It has 32 bit has application support, more application support, while 64 bit has less application support. Performance of 32 bit is less efficient, while performance of 64 bit is highly efficient. And 32 bit basically contains all the old technologies of Windows, like all the older versions like Windows 7, Windows XP, Windows Vista, and 8 and Linux, while 64 bit has Windows 10, Windows 11, Mac. So it's basically all 64 bit. Usually in our system we have 64 bit. So as I told you before, as we have discussed in this playlist, like types of operating system: batch operating system, interactive operating system, real-time operating system, network operating system, multi-user operating system, multi-programming, multitasking. We have discussed all of these concepts briefly in our videos. So here's a small self-task of multi-programming. As you can see, in operating system we have 3 different processes, all are loaded into the CPU. P1 is first loaded, so P2 will wait until P1 is executed, and when P2 is executed, P3 is while waiting for P2 to be executed. So another self-test of multiprocessing, multiprogramming. Multiprocessing means we have multiple processors. As you can see, we have 4 CPUs, and we have 3 processes loaded into our MM. MM is main memory, and each will wait for its execution. And in the right we have multi-threading, like we have context switching capabilities of 4 different threads. Another self-test, multiprocessing, multitasking. So here is simultaneously multiprocessing and multitasking is happening. As you can see, like we have MS Word and web browser, it's based on context switching, and we have it's working on processor 1, and while we have processor 2 of email and internet. So we have context switching, multiprocessing, multitasking, and we have on the right multiprocessing, multi-threading. Like we have opened MS Word, and first we open the MS Word and we are writing some documents, we are writing some lines, and it will check the grammar, it will highlight the errors, mistakes, spelling mistakes. So it's basically multi-threading. And why is multi-processing? Because it has two CPUs and each has own context switching capabilities. So here's the last one, self-test, multi-threading and multitasking. As you can see, word processor, we have graphics responding to keystroke, grammar check. So it's basically multi-threading application of a CPU. And while multitasking is operating system, we have opened like 3 different apps, browser, Excel and VLC media player, and we are context switching between each of them. So it's basically multitasking. So that is the end of our first lecture of this playlist, and in the later part of our playlist we will discuss new concepts. So basically I teach you today about process, threads, types of different operating systems, and we done some self tests. So thank you so much guys. If you find my videos helpful, valuable and can benefit you in any way, then please subscribe to my channel, like, comment, give reviews. Thank you so much guys, and I'll see you next time. Bye bye.